Today we will discuss an example of how to multiply two vectors by cross product. Suppose we have got two vectors, a is equal to 2i plus 3j plus 4k, and we have got other vector I plus 2j plus 6k. We are supposed to cross product the two. How can we do it? We can do it like this: a cross b is equal to ijk 2 3 4 1 2 6. Now you might ask why it's plus, why it's minus, why it's plus. It is because in determinants we use the cofactor concepts, and in that we have to multiply the corresponding row, corresponding element with this particular factor, minus 1 raised per I plus j, where I is the number of the row and j is the number of column. Now here you can say we have got row number 1, column number 1, that's how you can obtain I. And minus 1 raised power 1 plus 1, that is 2, that's equal to 1, that's why here it's plus. And in place of j, it's first row, second column. And first row, second column, we have to introduce a term that is either plus 1 or minus 1. How can we decide that? By using this formula minus 1 raised per I plus j. In this case, first row, second column, we have got minus 1 raised per 1 plus 2. That's minus 1. That's why here it's minus. And then plus, we have got the first row, third column, minus 1 raised per 1 plus 3. That's minus 1 raised per 4. That's 1. That's why plus k. Now, going ahead, plus I, that's I into, then we will blind the corresponding row and the column. We will multiply from top to bottom, and subtract the two terms. 3 into 6 minus 4 into 2. 3 into 6 is 18, minus 4 into 2 is 8. Then minus j, we have to blind this corresponding row and corresponding column. Then top to bottom, multiply them. That is 2 into 6, 12, minus 4 into 1, that's 4. Then 12 minus 4, that is 8. Then plus k, we have to blind this corresponding row and this corresponding column. Then multiply top to bottom. 2 to 2, that is 4, minus 3 into 1, that is 3. So we will obtain 18 minus 8, that is 10i, minus j into 12 minus 4, that's 8. J plus 4 minus 3, that's 1, that's 1k. So a cross b comes out to be 10i minus 8j plus k. That is the cross product of these two vectors. Now suppose we are asked, find a unit vector perpendicular to the plane containing a and b. I told you all again in the last video that a unit vector perpendicular to the plane containing a and b can be obtained by neta, and neta is equal to a cross b divided by magnitude of a cross b. Now what's a cross b? It's tan I minus 8j plus k, and what's the magnitude of a cross b? That is root of x component square plus y component square plus z component square. So x component is 10, y component is minus 8, and z component is 1. That's root of 10 square plus minus 8 square plus 1 square, and that comes out to be root of 165. So we have got the answer of neta is equal to tan I minus 8j plus k divided by root of 165. Now we can write it in terms of the components as follows: 10 divided by root 165i minus 8 divided by root 165j and plus 1 divided by root 165k. Now suppose we will be asked a question, find a unit vector perpendicular to the plane containing a plus b and a minus b. How we will do that? We will first find a plus b, let that be c. We will find a minus b, let that be d. Then we will cross product the two, that's c cross d, that is I, j, k. Then the corresponding component is 3, 5, 10 as follows: 1, 1, minus 2. Then we can obtain neta as c cross b divided by magnitude of c cross d. You will do it yourself and then give me the answer in the comments.